Simplify rational expressions. Our objective is to simplify rational expressions, as well as identify excluded values of rational expressions. Why learn this? The shapes and sizes of plants and animals are partly determined by the ratio of surface area to volume. Let's start with, what is a rational expression? It's an algebraic expression whose numerator and denominator are polynomials. So let's start with the identifying of excluded values. So we have 5 over 8 times r. We want to find a way to make our denominator 0, because then you have something that's undefined and you can't work with it. So it becomes excluded. So we have 8r equals 0, and we solve for r and we end up with 0. So the excluded value is simply 0. Let's step it up a notch to one that might be a little bit more challenging. So we have 9d plus 1 in our numerator, and then in our denominator we have d squared minus 2d. And we want to set our denominator equal to 0. So we have d squared minus 2d equals 0. And now we can factor. So we're going to factor out a d, so we're left with d minus 2 equaling 0. So we want to use the 0 product property. If you remember what that is, it was when we took each of our pieces, we set each of them equal to 0 separately to get our possible values. So for our first one here, we're going to have simply d equals 0. And to set this second piece equal to 0, we're going to end up with d equaling 2. So the excluded values are 0 and 2. Let's try one with a trinomial in the denominator. So we want to set our denominator equal to 0. And in this case, we want to factor. So we're going to factor. We want two values that multiply to give us 6, but when we add them, we get 5. So in this case, it will be a positive 2 and a positive 3. And then we're going to set each piece equal to 0 separately. So in this first one, we end up with x equals negative 2. And in the second one, we end up with x equals negative 3. So our excluded values are negative 2 and negative 3. Take a moment, pause the video, and try this next one on your own. When you return to the video, the answer will be revealed. And there you have it. Let's try one that's a little more challenging. So pause the video and try this one. And there you have it. So now let's try one more with the trinomial in our denominator, and then we'll move on. And there you have it. A rational expression is in its simplest form when the numerator and denominator have no common factors except 1. Remember that to simplify fractions, you can divide out common factors that appear in both the numerator and the denominator. You can do the same to simplify rational expressions. So just because we throw a bunch of variables in there, this doesn't change. Let's take a look. So we have 3t to the third divided by 12t. So if we simplify our 3 over 12, that's going to simplify to 1/4. And then we have t to the third over t. So the bottom t is going to be gone, and the top t comes down to 2. So you end up with 1t squared over 4, or t squared over 4. And then t cannot equal 0, because if we go back to our original, if t equals 0, it's going to be undefined. So that's our excluded value. Now let's try one from top to bottom. So we're going to factor our numerator. So we're going to take out a 3x, which leaves us with x minus 3 inside. And then that is over x minus 3. Well, since we have it in both the numerator and the denominator, we can cross it off, leaving us with only 3x. However, don't forget about that excluded value. So we're going to look at our denominator and what is going to cause our denominator to be 0. Well, in this case, x cannot equal 3. So when we simplify, we end up with 3x, but x can't equal 3. Take a moment, pause the video, and try C on your own. When you return to the video, the answer will be revealed. Well, you can't simplify it. However, there is still an excluded value. C can't equal -5. Take a moment and try these next 3 on your own. When you return to the video, the answer for each will be revealed. And there you have it. However, real quick, in problem F, notice how there are no excluded values. Basically, for there to be an excluded value, you would have to have a -2 of some sorts. And you can't because you have p squared, and that's going to force it to be a positive. So therefore, all you have is the simplified version, which is 6p. All right, so from now on in this chapter, you may assume that the values of the variables that make the denominator equal to 0 are excluded values. You do not need to include excluded values in your answers unless it's specifically asked for. This is just to save us some time and to get you to focus on the newer pieces of material. So, with that being said, let's try simplifying rational expressions with trinomials. So let's factor our denominator. So we're going to end up with two numbers that multiply to give us -5 but add to give us -4. And in this case, we'd end up with k plus 1 and k minus 5. And if we look, our numerator and denominator both have a k plus 1, so we can cancel them out. However, how do we write k minus 5 when it's on the bottom? We want to make sure it stays on the bottom. So what are we going to place on the top? We need a placeholder. 0 would equate the entire problem to 0, so that's not going to work out. What you can do is you can place a 1. So you have a 1 on top, and then you have a k minus 5. Because essentially, when you're crossing two things off that are the same, you're stating that that's 1. Because k plus 1 over k plus 1 is equivalent to 1. So now let's try B. We're going to want to factor our numerator and our denominator. So take a moment and pause the video and do that step. So we're going to factor the numerator and denominator. So if you struggled with remembering how to factor this binomial since there was no greatest common factor to pull out, remember it was a difference of two squares. So we have a y plus 4 times y minus 4 over a y minus 4 times y minus 4. And we can cancel one of those off, leaving us with y plus 4 as our numerator and y minus 4 as our denominator. Take a moment, pause the video, and try these next two on your own. When you return to the video, the answer for each will be revealed. And there you have it. So now let's step it up a notch. Now let's try simplifying rational expressions using opposite binomials. So to start out, we still factor our numerator and our denominator. So we're going to factor out our greatest common factor, which is 2, leaving us with x minus 5 on top. And then we have a difference of two squares. So we're going to have 5 minus x and then 5 plus x. However, notice how you have an x minus 5 and a 5 minus x. They're perfect opposites of each other. So what we can do is we can write one opposite binomial, and then we can multiply by -1. And when we do so, our numerator is going to stay the same, so we're just going to kind of rewrite that. However, our denominator, because we're trying to force this to look like that, what we're going to do is we're going to multiply by -1. So we have -1 times, and then we have x minus 5. And then 5 plus x. It's kind of like multiplying a negative times a negative, because you're flipping this around. So the negative is just going to kind of carry itself through the problem, because by flipping this around, it's forcing there to be a negative that follows suit. So now we can cross off our x minus 5 and x minus 5, leaving us with a 2 over -5 plus x. Or you can write the negative out in front, so it's negative, and then 2 over 5 plus x. Either way would work. So let's try another one. So step 1, factor. So on the top we have a greatest common factor, so we factor out a 2, leaving us with a 1 minus m. And then in our denominator we've got a trinomial. However, we can factor out a 2 first. So we end up with 2, and then we have m squared plus m minus 4. And now we can factor that. So our numerator stays the same. We have 2, and then we have 1 minus m on top. And now we have a 2 outside. And then inside our double sets of parentheses, we have a m plus 2 and an m minus 1. However, same thing as last time. Notice how you have 1 minus m and m minus 1. They're perfectly backwards from each other. So we want to make this one look like our numerator. So we're going to multiply by -1. And that's kind of going to look like this. So our numerator stays the same. We're not doing anything to that one. And then our denominator, we have this other stuff here. We're just going to kind of throw it back down. So we've got 2 times m plus 2. That's going to kind of stay there. However, we're going to throw in a -1 to force this to go the other way. So now we're going to have a 1 minus m. And now we can cross some things off. So we can cross off our 1 minus m and 1 minus m. And then we have a 2 in our numerator and denominator. So we can go and cross those off as well. Well, that leaves us with a 1 in our numerator. And then we have this -1 times m plus 2. So the negative is going to sit out in front here. And then we have m plus 2. And this ends our video lesson on simplifying rational expressions.